We're going to talk about the distributive property. Distributive property involves three numbers, typically A, B, and C in most general cases. And it talks about taking a numerical quantity and multiplying it to a sum or a difference of two other quantities. So you'll see in this case, I call it leapfrogging. If A is multiplied by the sum of two terms, that's the same as multiplying A by the first term and A by the second term and then adding the two terms up. If A is multiplied by a difference of two terms, then that's the same as multiplying A by the first term, A by the second term, and taking the difference of those two products. And you can see that in this problem here. We have 3 times the quantity of 2 plus 5. I distribute the 3 to each, and you'll notice the output 3 times 2 plus 3 times 5, etc., etc. So if I want to rewrite this expression using the distributive property, I distribute 8 to each term, and in this case I have actually 4 numbers, which is fine. You can use any number of numbers, to each of these terms within the expression. I get 32x, 48y, and 40. Talking about like terms are two or more terms having the same variables, and their corresponding variables, the ones that are alike, have the same exponent. So what I want to do is I want to identify all pairs that are like terms. You'll notice in this case each has an x, and that x doesn't show a power, but the power in each case is actually 1. Now these numbers in front, which are called coefficients, so the 200 and the 8 are coefficients. Being like terms doesn't state any restrictions on the coefficients. So all we're looking at the variables and their powers. These two then are like terms. Now I notice in this case I have an x and an x, but in this case my x has a power of 3 and my x has a power of 1. Right off the bat, corresponding exponents are not the same. So these are not like terms. I have a w and a w and a z and a z. Notice the w's both have exponents of 7 and the z's both have exponents of 5. Coefficients don't matter. So these two are like terms. Now we have an expression that could involve one or more like terms within it, and we want to identify the like terms in this expression. So here I have an a and a b in each of the elements in this expression, or each of the terms. In this case, my a is to the first, my a is to the second here. The first and second are not like terms. Notice my third term has an a to the first in it. My first term has a b to the second, and so does my third term. So this first term and third term are like terms. In the second example, it's a little simpler. I have single variables of a and b in this case, so the a's match, and then the b's match. And those are like terms of a and like terms of b. In this last expression, I notice I have an exponent of 1 with the x and 3 of the y. This only has a matching y exponent. Now the term must have all variables matching. So this y cubed is not a like term with the xy cubed. And finally I have an x cubed y, which doesn't match any of the exponents in either of the first two terms. So there are no like terms in this last expression. And then as a general rule, when we want to add or subtract like terms, we identify that they're like first of all. and then we add or subtract their coefficients, and we leave the exponents as is. So in this case, let's identify those like terms. These are the same problems we just had. These are my like terms. My coefficient in front of the first term is a 5. In front of the second term, there really isn't one, so that's an unwritten 1. And so I'm going to combine my like terms by adding their coefficients. So 5 plus 1 is 6. I leave the variables and exponents the same. 2a squared b is not like with anything else, but I have to include it in my sum, and that's my final answer. In this case, we said the a's match and the b's match. So in this case, I take the coefficients of each. 16 and 21 go to 37, and I keep the variable a and its power. And 30 and 17 is 47, and I keep the variable b and its power. Finally, there were no like terms, so it stays as is. 3xy cubed minus 2y cubed plus 5x cubed y, or you could just say already simplified. Next example. So here I have two expressions that I'm asked to add together. Now, just because they're in parentheses doesn't necessarily mean that within the parentheses I can combine anything. In fact, in each of these, there are no like terms within either parentheses. But if I want to look overall and say, do I have any x cubes in any of these terms, the answer is no. So I write my x cubed down because I know that will be in the sum, or in the sum. Do I have any x squared y's? Well, notice this term and this term are x squared y. I have a negative 5 and a positive 5, which is 0, so these reduce out. Next, I look for y cubes, and I notice I have a y cubed here and a y cubed here. I'm going to add the coefficients, so I have a 1 as my first term, and a negative 2. If I add 1 plus negative 2, I get negative 1, and I'll just write negative 1, y cubed. And then finally, I have an xy squared term, so I'll give that a star, and there's an xy squared again. This is negative 3. There's no coefficient here, so that must be an unwritten 1. Negative 3 plus negative 1 gives me a negative 4 xy squared. And that's my sum. Now in this last example, I have some distributions I have to do because I have a number times a sum, a number times a sum, and a number times a sub. Now, here's what I choose to do. I'll distribute my 2 through. I'll get 2w to the 4th. 2 times 3 is 6w. I consider this a negative 4. So negative 4. In fact, what I'd probably rather do is change my subtraction to an adding of the opposite. So then I can really see that negative 4 right there. So a negative 4 times a positive 2 is a negative 8. So I'm going to add a negative 8w squared. And then I'm going to add a negative 20w. Finally, I see another subtraction. I'm going to add the opposite. And I just do this now while we're all learning what's going on. And I get a positive 20w and a negative 10w to the 4th. Again, I'm going to look for like terms. So here's a w to the 4th and here's a w to the 4th. Add 2 plus negative 10 and I get negative 8w to the 4th. W to the 1st and w to the 1st, I notice those match. And here's another w to the first. So there are 3 like terms there. I'll add 20, negative 20, and 6, which gets me 6w. And finally, I have a w squared term, which doesn't match with anything, so I have a negative 8w squared. Now, if you wanted to, you could leave the answer as negative 8w to the fourth, and some teachers will prefer that you write these in descending powers, so this could be minus 8w squared plus 6w. I'm not going to get stuck on decreasing powers, but just know that there will be some teachers that require that of you in your math career. We're going to take and write an expression now for the verbal, and we'll indicate the properties. So we have 4 times the difference of f squared and g. So times means a product, difference means a subtraction. So we have 4 multiplied by a difference of f squared and g. And that's going to be increased by, so I'm going to add the sum of f squared and 2g. And we're done. So now let's simplify. We multiply 4 by f squared. I get 4f squareds. I multiply 4 by a negative g, because I'm going to take and add the opposite here. Add the opposite. So that gets me plus negative 4g. That's added to f squared plus 2g. Combine like terms, f squared, 4f squared and 1f squared is 5f squared. Negative 4g and 2g, add those up, and I get plus a negative 2g. And again, I could rewrite that if I choose to as saying 5f squared minus 2g. It's up to you. I'll take either one. And that's all we've got for today. You've got 3 multiple choice questions. Grind those out, put the answers on the form, and we'll talk about them tomorrow.